please take?
Oh, I've got a task for him. Shall I put it on his desk?
Don't be daft, they'll get covered up with the other sheets of paper.
Oh, I've got him after. What are you doing anyway?
I'm doing a project on plastics.
We're doing plastics in chemistry, but these aren't plastics. This bag is plastic.
Sorry, Bobby, these are all plastics. This is the stuff that you use to make polythene bags. That's a polythene bag that your ball's in. Washing up basins and Tupperware containers, which you find in the kitchen, are also made of polyethylene. But there are lots of different kinds of plastics. These other plastics are used to make many different articles.
Like what?
Well, polyethylene's used to make bags like yours. And the window, it's made of perspex and it's vandal-proof.
So it is. It's not made of glass. What do you use these plastics for?
It's to do with the properties.
Eh?
Perspex is used for these windows because it doesn't break so easily as glass. It's tough.
This poly stuff isn't very strong. Look.
No, you're quite right. Polyethylene isn't strong, but it's strong enough for shopping. It does stretch and tear though, but because it's one of the cheapest plastics, it's best to use. And it's useful for wrapping things too, because you can see through it. It's transparent.
Oh, I wish I could find something stronger than polyethylene for my football.
Oh, but there is something stronger. Polypropylene. It's much stronger.
Well, it just looks like the other one.
I suppose it does. Let me show you how polypropylene pellets like this are made into bags which are strong enough to hold half a ton of fertilizer. First, the pellets are melted. This is possible since polypropylene is a thermoplastic, which means it will soften when heated and change shape. There are other plastics which will not change shape when heated. They're called thermosetting plastics. The molten polymer is then squeezed through a slit to form a thin sheet, and it's cooled by passing through a tank of cold water. It's rolled and slit into tapes. The uneven edges are taken away and put back in at the beginning. Less waste means a cleaner environment and more profit. At this stage, the polypropylene tape is not very strong. Watch. The tape is strengthened by stretching. It's heated again in this box. Remember, it's a thermoplastic and it's stretched about 7 times its length by the rollers at the far end, which are moving 7 times faster than the first set. See how much stronger it is this time?
Yeah.
Now it's wound onto spools ready for the circular looms. These circular looms weave a tube of polypropylene fabric which is used to make the bags. There are no side seams in these bags. A bag without side seams is easier to make and will be stronger. The reels hold about 1,000 meters of fabric. It's then cut, printed, you'll find out about these MPK values in the next topic, and sewn. Let's see how strong they are. This bag weighs less than 1 kilogram and can support a load in excess of 2.5 tons. That's stronger than steel. Normally, it would hold half a ton of fertilizer, so there's a safety factor of more than 5 to 1.
What else is polypropylene used for?
The all-weather pitch where you play football is made from polypropylene.
No, it can't be. It's green.
No problem. You can make polypropylene any colour you like by adding a pigment. Watch this. Clear polymer pellets and the green pigment pellets are sucked into this machine, where they're mixed and melted.
Because it's a thermoplastic.
Right, Bobby, you're getting the hang of this. The molten mixture is squeezed through holes in a metal plug like this one. It's called a die, and then the strands are cooled in water, dried with a blast of air, and cut into pellets. The pellets are then put into a similar machine called an extruder, which melts them and squeezes the molten plastic through a slit onto these rollers. It's cut into tapes, which are heated and stretched to make them stronger.
But how does stretching make them stronger?
Well, plastics are polymers. Polymers are very long molecules with thousands of atoms joined to make chains. When they're melted, they tend to curl up like this. And when the tape's stretched, the polymers uncurl and lie neatly side by side. This makes the tape stronger. The tape's wound onto bobbins and then taken to another factory where it's made into artificial grass. You can have any colour you like. This sort of polypropylene tape is also woven to make carpet backing, a replacement for the natural fibre jute. Many other polymers can be extruded and made into fine threads and used to make clothing. Nylon and polyester are just two examples of synthetic fibres.
What does synthetic mean?
It means man-made. The plastic material, the polymer, is made in a chemical works from simple chemicals called monomers. Monomers are made from the products of a distillation of crude oil. Nylon is a synthetic material and wool's a natural one.
My tie's polyester. That's synthetic.
Yeah, correct. We use synthetic fibres to replace natural fibres, like wool and cotton.
What else can we use synthetic materials for?
Many things, but I'll show you just one more example. The door and windows here are made from a plastic called polyvinyl chloride, PVC for short. It's used to replace wood because it won't rot and it doesn't need to be painted. These lengths of PVC were made from pellets of the polymer by melting and extruding. It's cut to the required length and then...
Glued?
No, Bobby. The pieces are joined by heating. PVC is a thermoplastic too. Those metal plates are heated electrically and both ends of the PVC melt. The plates have a non-stick coating just like frying pans. The two molten ends are then pushed together. You can see the extra PVC oozing out of the joint, and they're allowed to cool. The plastic sets joining the two parts.
Won't that make it weak at the corner?
Not at all. Watch this test. The weld's stronger than the frame. The finished product is ready for the customer.
Hey, plastics are great. Is there anything bad about plastics?
Well, they're non-biodegradable.
Oh no, what does that mean?
Well, it means that plastics don't rot when they're thrown away. The bacteria in the soil can't break up the large polymer molecules into smaller ones. You must have seen the mess at some picnic sites where plastic bags, drink cartons and cups are just left lying around.
Why not burn plastic rubbish?
Most domestic rubbish does end up at the incinerator, but burning it's not as straightforward as you would think. The furnace must be hot enough to completely burn the plastic to carbon dioxide and water, about 900 to 950 degrees Celsius. But just to complicate things, the temperature must not rise above 1100 degrees, otherwise nitrogen oxides will form. Oxides of nitrogen make acid rain. The waste cuttings from this factory will not be burned. They'll be sent for reprocessing. Burning is wasteful. The crude oil from which plastics are made is a non-renewable resource. That means that one day the supply will run out. Burning also adds carbon dioxide to the atmosphere. Remember the greenhouse effect. This granulated PVC can be sold to make other articles, such as drain pipes, thus making our supply of crude oil last longer.
I've also heard that when plastic burns, you get poisonous fumes.
You're right. Come here, I'll show you. This is polystyrene. In a house fire, that kind of smoke can kill within minutes. There are now new rules about the type of plastic and synthetic fibres which can be used in furniture. Furniture manufacturers must use plastics which are specially treated to stop them burning so easily. This should reduce the number of deaths which occur in fires in the home.
That was really interesting. I'm off to play football on the synthetic, non-biodegradable, thermoplastic polypropylene pitch. See ya.
Great, bye.